All right, in Math 20-1, we're looking at the last topic of Chapter 1, 1.5, Infinite Geometric Series. Well, first of all, there's two different types of infinite geometric series. There's convergent series, and this is where, if you'll notice on this graph, the sums are small, and what's going to happen is that the common ratio is small, and as the numbers get added and get smaller and smaller and smaller and smaller, it's going to approach one value. Notice the sum of the first 5 terms in this sequence is, and the series is 7.75, 7.93, 98, 99, 999, 9998, and then 9999. And as the number of terms increases, the sequence of partial sums approaches a fixed value of 8. Therefore, the sum of this series is said to be 8. This series is called a convergent series. Now, this is different from a divergent series. If you considered the series 4 plus 8 plus 16 plus 32, you notice that the numbers are getting further and further apart. Notice also that the common ratio is going to be 2. And as the number of terms increases, the sum of the series continues to grow. The sequence of partial sums does not approach a fixed value, and therefore, this sum of this series cannot be calculated. The series is said to be a divergent series. If we graphed this one, you'll notice that the numbers just keep getting bigger and bigger and bigger and higher and higher. Now, you know the formula for the sum of a geometric series is S of n is equal to term 1 times 1 minus r to the power of n over 1 minus r. Now, what we're going to say is that the sum of an infinite geometric series, where r has to be between -1 and +1, it's the only way it works, can be determined using the formula. The sum, as we approach infinity, is going to equal term 1 divided by 1 minus r, where t1 is the first term of the series, r is the common ratio, and s sub infinity represents the sum of an infinite number of terms. Let's look at example 1. Decide whether the sum of an infinite geometric series. Decide whether each infinite geometric series is convergent or divergent, and state the sum of its series if it exists. Well, in the first case, notice that the term 1 is going to be 1, and our common ratio is going to be -1/3. How do I know that? Well, if I took -1/3 for the second term and divide it by the first term, 1, I'm going to get -1/3. Now, because r is between -1 and +1, being -1/3, this is going to be a convergent series, and we can find its sum. So we're going to take the sum, as we approach infinity, is term 1 over 1 minus r, and term 1 is 1, and 1 minus r is 1 minus -1/3. Now, 1 over 1 minus -1/3, the bottom is going to be 1 plus +1/3, or 3/3 plus +1/3, which means I get 4/3 on the bottom. 1 divided by 4/3 is the same as 1 times the reciprocal, 3 over 4, so the sum is going to approach 3 over 4. That's it. If we took the second one, first of all, term 1 is +2, term 2 is -4, so that means that my ratio is going to be -2, because -4 divided by +2, term 1, is going to be -2. And when I notice that r is equal to -2, I've got a divergent series. And since r is not between -1 and 1, the series is divergent, and there's no sum. Here we go with example 2. Apply the sum of an infinite geometric series. Assume that h shaded square represents 1/4 of the larger square bordering two of its adjacent sides, and that the shading continues indefinitely in the manner indicated. The squares just keep getting smaller and smaller. Write the series of terms that would represent this situation. Okay, here's A. This is going to have a length of 1/2 the total times 1/2 the total, so its area is 1/2 times 1/2, or 1/4. Now, this length is 1/4 of the total length times 1/4, so that area is 1/16. The next one is 1/8 times 1/8, which is 1/64. Well, that's enough for me, so I can say A is 1/4, 1/16, 1/64, and that's going to continue. There's my series. B. The sum of this is going to be T1 over 1 minus R. Well, T1 is 1/4, and that's going to be 1 minus my common ratio, 1/16 divided by 1/4. That means my multiplier, my common ratio, is 1/4. So 1 minus 1/4 gives me 1/4 over 3/4, or 1/4 times 4/3. The 4's will cancel, and I'm left with 1/3. So 1/3 of the total area will be shaded. This takes us to the end of lesson 1.5, and your assignment is going to be to do page 63, numbers 1 to 12 and 15.